Alright, so like with the other integrations, we're going to start by doing what we're much more familiar with, which is differentiation. So I want you to first of all recall back to a whole 2 weeks ago and see if we can derive ln x.
Yeah.
What does that become?
1 on x.
1 on x. Purple. Okay. So if this process, if integrating is the reverse of deriving, what do we expect the integration of 1 on x to become? ln x plus c. Alright, so now derive ln 2x plus 3. Remember the derivative for the shortcut is f dash. We've got ln x dy dx. No, it shouldn't be ln x, sorry. ln fx. The derivative equals f dash x over fx. What do we get for ln 2x plus 3? What's the derivative of that? 2 over 2x plus 3, which means the integration of 2 over 2x plus 3 is?
ln 2x plus 3.
Very good. What if this was no longer a 2? What if this was just a 1 now? What would have to change about our answer? What would it become?
X plus 3.
ln 2x plus 3? What have I done? So this was a 2 before, correct? If it's now a 1, what do I have to do to my answer?
Plus c.
How much bigger is that?
1 bigger.
So, not 1 bigger,
2x plus 3.
twice as big, correct? That's twice as big, there's 2 times as much. So if I turn this into a 1, what do I need to do to my answer? It's divided by 2. Sweet. So for any linear reciprocal, which means it comes in this form here, it's linear because x is to the power of 1. So it's a linear reciprocal, it's on the bottom, and it's a linear function. That becomes ln whatever is on the bottom divided by the coefficient in front. Plus c. Cool? I did forget the plus c. And if we're thinking about it, that makes sense. If we look back at our first example, right? So I've just rewind. So this is the rule we need to know. And it's important that we do know this one because the rule on the sheet's not that helpful. So we need to make sure we know that rule. But if we look back at our first example, we're just going to dig a little bit deeper on it. I'll do it over here. And the first example states that we want the integral of 1 over x. How do we represent 1 over x when we're integrating? How should we represent that? When we've got it in the numerator, what do we need to do? A denominator, sorry. When it's in the denominator, what do we need to do? Take it up to the numerator. So that becomes x to the power of? Negative 1. What's the integration rule? What do we do? Add 1 to the power divided by the new power, correct? Yeah. So that, if we apply just our polynomial rule, we'd get, it's probably a good indication that there's another rule applying. Sweet. Because can you divide by 0? Not possible. We know that there is an integration for this function, but clearly this rule doesn't work, so we must need to use another rule. Happy with that? Remember this rule and you've got no problems, but that's the how. Sweet. We'll go through a couple of examples on the left here just to make sure that we are on board with that. Y equals the integration of 1 over 2x. Y equals the integration of 3 over 4x plus 6. And y equals the integration of 1 on x squared. Good luck.